Okay, so this is quite an easy sketch. What I'm going to do is output 0 volts gradually all the way up to 5 volts using PWM, which is of course here, PWM, and this is going to be over an amount of seconds, probably say 30 seconds or something, just rough. And when I do each step, or each increment if you like, I'm going to delay by 100 milliseconds, and then at the very end, when it's reached full speed, I'm going to wait for 5 seconds. Right, so this is how I'm going to do that. I've got byte duty. So byte is appropriate because it stores up to 255 numbers, and that's appropriate for analog write or PWM because that's the maximum amount of steps you can take. It's 255, so that's perfect. So I've got a variable called duty, and it's a byte. Then in the loop, every time it loops, which is, well, less than a millisecond, but anyway, every time it loops, analog write, pin 10, the value of duty, which to start with will be 0. So every time you loop, increment duty by 1, then if duty is less than 254, then just delay by 100 milliseconds. If it's not less than 254, then delay 5,000 milliseconds, which is 5 seconds of course, and then repeat. So it's pretty easy. So generally speaking, or very basically, it just goes up like this. The voltage will go up, 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 up until it reaches 5, and then it'll stay at 5 seconds, and it'll go shoot down, and up, 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 stay, shoot down, like that. Okay. So I'll just upload this thing now. Okay, so it's uploaded. Okay, so it's all uploaded, and we're all connected up here. I've got the voltmeter to show you the average voltage, which is coming out of the Arduino, to feed the transistor, which the transistor switches the power from the power supply. And of course, when it's closing the circuit, then it closes this circuit here from the power supply to the motor. We should be able to control speed that way, even though we're not directly powering the fan from the Arduino. It's quite clever. Anyway, so I'll just plug this in, and you can see there 0.4 volts. Maybe it'll just take a second or so to start up. Right, you can hear a hum from the fan. It's getting faster and faster and faster. It's getting faster. 3 volts, 4 volts, and there we go. That will be about 12 volts, and yeah, it's quite a lot of airflow, and you can see that it's starting again. Currently not really anything, it's not very powerful. I'll do something to demonstrate how powerful this thing is. Four volts, so that's pretty much full speed. Right, now, the capacitor. I'll tell you about the capacitor now. So, what happens if we don't use a capacitor? Right, if you don't use the capacitor, basically the fan doesn't deal with the switching very well, and it makes a noise. So, I'll show you now. Right, hopefully you can hear this. I'm not sure if you'll be able to, but hopefully you will. Can you hear that awful noise? Maybe you can hear it, I don't know. But as soon as I put the capacitor on, it's happy again. I'll put the capacitor. Okay, the capacitor's in, and you can hear that the noise has stopped. So there we go. So that's how to control a higher powered and a higher voltage device using an Arduino, but also being able to control its speed. Now, of course, this has its limitations, but for fans it's fine, because basically what this is doing is it's controlling the voltage. It's controlling the voltage from 0 volts to the maximum amount of volts which the power supply can handle. I suppose basically it's a bit like a switch mode power supply. So there we go. I hope you found this video helpful, and thank you for watching. Bye!